In this problem, we are going to examine a situation of a leaky faucet. This actually happened to me over break. My sink had a leak in it, and I woke up one morning with a 1/4 inch of water all over my floor. To start out with, we're going to annotate the problem. A faucet leaks at a constant rate of 7 gallons per hour. Suppose Y gallons leak in X hours from 6 a.m. So that's telling us when we are starting to measure how much water is coming out. Express the situation as a linear equation in 2 variables. So notice that my first step in solving any word problem involving rate was to annotate. Figure out what was going on in my situation using our classic circle the numbers, underline, represent, we'll get there, we're doing that symbolically, bracket the question that we are asked, and then write an answer sentence. Because the answer to this problem that I'm looking for is a linear equation in 2 variables, I'm just going to leave a box over here where I'm going to write my final equation. To start out with, I notice I've been given a constant rate. Let's write that rate as a ratio. 7 gallons per hour. And I know when I say per hour, I mean the ratio of 7 gallons to 1 hour. Now, if it's a constant rate, it should be equal to the amount leaked per time elapsed over any interval of time. This is like what we saw when we looked at Hal's speed walking. His constant speed was equal to his average speed, so distance traveled divided by time elapsed over any interval that he was traveling at, because he always was going at the exact same speed. I've got this information. I need to introduce X and Y. Well, X and Y in the example are supposed to tell me an amount of leaking after X hours, that Y gallons of water leak over the X hours since 6 a.m. That tells me that I can set this equal to my constant rate because it gives me a leak per an amount of time. So I'm going to set this equal to Y gallons over X hours. And notice that all of the places where I've written this out, I've got gallons in the numerator and hours in the denominator. I want that to be consistent because that's what's making these ratios be equal. If I simplify the equation, on the left-hand side, I have 7, because 7 divided by 1 is 7. And on the right-hand side, I have Y divided by X. But that is not a linear equation as I've set it up. So how can I take this equation and make it so that Y is isolated from X? Y is divided by X. So in order to isolate Y, I need to use the inverse operation. I'm going to multiply both sides of my equation by X. On the left-hand side, I get 7X. On the right-hand side, I get Y times X divided by X. So I can rewrite that as Y times X divided by X, and X divided by X is 1. I get Y times 1, or just Y. Simplifying, I notice I now have an equation telling me what is Y in terms of X. Y equals 7X. Is that a linear equation? Well, is it of one of our 2 linear equation forms, y equals mx plus b, or number times x plus number times y equals number? Yeah, it's actually a slope-intercept form. The b in this case is 0. Let's go on and look at the next question. Now we're told another faucet leaks at a constant rate. The table below tells us how many numbers of gallons that faucet leaks in a selected number of hours. So we would like to know the rate at which this faucet leaks. I want to think again about the fact that the rate should be equal to amount leaked over time elapsed. So I'm going to pick 2 points, 2 pairs of data, a time period X and the amount of gallons that have been leaked at that point Y. I'm going to pick 2 points like this. So I'm going to pick my point 1 that I am selecting is going to be the point 2, 13. I can think of this as x1 and y1. Next, I'm going to pick my point 2. And I can pick any point, but I'm going to choose to just pick the next one. 4, 26. So that gives me my x2 and y2. Now that I have these 2 points, I'm going to use this to find out how much did we leak over what length of a period of time. The amount leaked, well, that's the amount that's leaked over this 2-hour period between the start and the stop, hour 2 and hour 4. So the amount leaked is going to be the gallons that leaked over the whole 4 hours minus the gallons that leaked over the first 2. So it's going to be y2 minus y1. 26 minus 13. Look familiar? It's our rise. And the time elapsed, well, that's the change in these x values. It's the amount of hours that passed between these 2 data points that I was considering. x2 minus x1, which is 4 minus 2, which is our run, in this case, of 2 hours. So if I take the quotient of amount leaked over this time period of 2 hours, the rise over the run, that's giving me the ratio that I'm looking for. That gives me my constant rate. So the faucet leaks 13 gallons per 2 hours, or if I convert 13 halves gallons per hour, and 13 halves can be rewritten. Let's rewrite it as a mixed number. So I'm going to split off 13, the closest multiple of 6 to 13 that's smaller is 12. So I'm going to rewrite 13 halves as 12 halves plus 1 half gallons per hour. So 6.5 gallons per hour. And that's the rate at which the faucet's leaking. And it is not by coincidence that what I did here to find the steps for determining the rate at which the faucet leaks is I pick 2 data points, I compute the slope of the line between them, because that is equal to the constant rate, because it's the average rate of change.